Hello everyone. So this is a video regarding the atom model done by Rutherford. So every one of us know the basic building block of matter is an atom. Previous centuries, many of the scientists have done many suggestions on the structure of an atom. For example, John Dalton, J.J. Thomson, they have suggested many theories regarding the structure of atom. But those theories were discarded because they are not justified by the experimental results. The first acceptable theory was given by a scientist called Ernest Rutherford. He is a British physicist and he is known as the father of nuclear physics. Now in today's class, we are going to see the atom model done by Rutherford. To find out the atom model of an atom, Rutherford has done one experiment, and that experiment is known as alpha particle scattering experiment. Okay, so Rutherford, with the help of two other scientists, Giger and Marsden, has done this experiment. So here we can see one new term, that is alpha particle. So many of us maybe have the doubt, what is this alpha particle? So I will tell you what is this alpha particle, then we will go for the experimental setup. Now, what is an alpha particle? An alpha particle is a positively charged particle which comes out from a radioactive nucleus. For example, do you know what is a radioactive nucleus? A radioactive nucleus is an unstable nucleus which comes to a stable nucleus by emitting some radiations. That radiations are of different types like alpha particles, beta particles, gamma particles, etc. You will study about those things in the next chapter, nuclei. Now, for our experiment purpose, we need what is this alpha particle. So, alpha particles are positively charged particles, and now we know that alpha particles means they are the nucleus of a helium atom. So maybe everyone of now you know what is a helium atom. Helium consists of 2 protons, 2 neutrons, 2 electrons. So its atomic number is 2. If you are representing it as an atom, its atomic number is 2, mass number is 4. The nucleus of a helium atom means it consists of 2 protons and 2 neutrons, which means that alpha particle means it is the nucleus of a helium atom. So it has a 2 proton charge, or it is a positively charged particle, and the charge of helium nucleus is a +2 electronic charge, because we know that the charge of a proton is the same as the charge of an electron. So 2 protonic charge means the charge of helium nucleus is, or the charge of alpha particle is +2 electronic charge. So this Rutherford has used this alpha particle in his experiment. Now we will see what is the experimental setup made by Rutherford. So this is the experimental setup done by Rutherford to identify the structure of atoms. So here we can see a radiation source which is emitting alpha particles, and that alpha particles are incident on a gold foil, and the scattered alpha particles were collimated into a fluorescent screen. The fluorescent screen is made of zinc sulfide material. Now what he done is he bombarded very thin gold foil with alpha particles. The stream of high energy alpha particles was directed and the number of alpha particles scattered in different directions were analyzed. Okay. The thin gold foil had a circular fluorescent screen around it. Whenever alpha particles struck the screen, a tiny flash of light was produced at that point. Now, what is the aim of this experiment? Why the Rutherford has done this experiment? To study the distribution of number of alpha particles as a function of scattering angle. Now here, the scattering angle means the angle between the incidence and the scattering. The direction of incidence and the direction of scattering. Thus, angle is known as angle of scattering. Now, you can see that most of the alpha particles are scattered without much deviation because they are penetrating through the gold foil and incidenting on the fluorescent screen. And only very few number of alpha particles were scattered with some angle, and only one or two or very less number of alpha particles were retraced back, which means that for the particles whose scattering angle is less, like 0 degree, 1 degree, 2 degree, the number is more. And when comes to 90 degree, the number is decreasing. And when comes to 180 degree, the number is the least, which shows that as angle of scattering increases, the number of scattered alpha particle goes decreasing. Now we can see a graph from the experimental data. That is, Rutherford has plotted a graph between angle of scattering along x-axis and number of alpha particles scattered along y-axis. This is the shape of the graph. If you analyze the graph, you can see that for small angle of scatterings, 0 degree, 20 up to 20 degree and all, you can see that for 0 degree, the number of scattered particles is very high, around 10 raised to 7. And when the scattering angle is increasing, the number of scattered particles goes on decreasing in a very fast manner. So this shows that when theta is very large, because when theta is very large, this nucleus of gold atom, theta large means that should repel the alpha particles. Then only the theta becomes 180 degree. Theta 180 degree means that the alpha particles are retracing. For retracing or repelling, the positive charge of the gold atoms should repel the alpha particles, which implies that a very less number of alpha particles are repelled, which implies that the positive charge of the atom is concentrated in a very small volume, and that part has given the name nucleus. So the name nucleus was first chosen by Rutherford. And what about the remaining portion? The remaining portion is empty, or the remaining portion consists of electrons. Now the question is how these electrons are arranged. The electrons are revolved around the nucleus in some specific orbits. So the name orbits also given by the scientist Rutherford. Now you can see the main observations from scattering experiment. The first observation is most of the alpha particles were passed through the gold foil without any deviation, which implies that Most of the atom is empty. Then the second observation is some of the alpha particles were scattered through an angle and some of them in large angles. And the third observation is a very few were reflected back, which means that the positive charge of the atom is concentrated in a very small volume. Now, to develop the theory of Rutherford, he has made some assumptions on this experiment. The first assumption is alpha particle and gold nucleus are point charges. So, what are point charges? Point charges are very small charges when we compare the radius of the charge to the distance it occupies or to the distance which we are involving. If the radius of the charge is very small when compared with the distances, then that is known as point charge. So here alpha particle and gold nucleus are considered to be point charges because the repulsive force or the attractive force, to calculate its amount, we are using the Coulomb's law of force. And you already studied that Coulomb's law of force we are applying for point charges. And the second assumption is the scattering of alpha particles from the gold atoms were due to the Coulombic interaction between the positive charge of the alpha particle and the positive charge of the gold nucleus. So, the attractive force or the repulsive force is given by the Coulomb's law. And the third assumption is the nucleus of the gold atom is very massive compared to the alpha particle, and hence it remains stationary during the experiment. That is, already in 11th class you have studied about collisions. So here the gold atom, the mass number of gold atom is 79 and the mass number of alpha particle is only 4, which means that when we compare the mass of gold atom, it is highly massive compared to the alpha particle. So when the alpha particle hits on the gold nucleus, it remains stationary. And the fourth point is, as the gold foil is very thin, alpha particles will not suffer multiple scattering. So the gold foil which we have taken is very thin. So one alpha particle will incident on one atom and it will get scattered. It will not get collide with another atom and multiple scattering is not happening. So these are the main assumptions which made by Rutherford to develop his theory. Now we can discuss the trajectory of alpha particle. So you can see in this diagram, the angle is taken on the y-axis and its path is given in the diagram. So 0 degree, which means that the alpha particles which are incidenting through origin, they are incidenting directly on the nucleus and they are suffering a large collision or large scattering. So after the collision, they are coming back. And when you move away from the nucleus, the alpha particles move away from the nucleus, the angle of scattering or the deviation is decreasing. The amount of deviation is decreasing. And when we go far away from the nucleus, there is very less deviation. And if you go again, the alpha particles will pass without any deviation. So this alpha particle trajectory also shows that the mass of the atom is concentrated in a very small region, and that very small region has positive charge, which means that the positive charge of the atom is concentrated in that small volume called nucleus, and this nucleus repels the alpha particles. So when the alpha particles are going away from the positively charged nucleus, they are suffering less deviation, and when it is out of the range of that nucleus, they are moving without any deviation. So we can see that there is a variation in the theory formed by Rutherford with the theory formed by J.J. Thomson. J.J. Thomson's theory says that the positive charge of the atom is embedded in the atom in a uniform manner, and that model is known as plum pudding model. But now Rutherford has proved that the positive charge of the atom is not embedded uniformly. It is concentrated in a small region, and the electrons are revolving round the nucleus in some specific orbits. Now we will see the conclusions of Rutherford's model from the experiment he has done, that is from the experiment of alpha particle scattering experiment. The first point is the positive charge and most of the atoms density concentrated in a very small region called nucleus. The second point is the nucleus is surrounded by electrons which are moving in a specific path called orbits. The third point is electrons and the nucleus are held together by electrostatic force of attraction. So the electrons are revolving around the nucleus in some specific orbits, and they are held there by Coulomb's attractive force. And the atom model resembles the solar system. We already know what is the solar system. The sun is in the center and the planets are revolving around the sun. So we can compare the Rutherford's model with the planetary model. That is, in place of sun, the nucleus plays the role of sun and the electrons plays the role of planets. Therefore, the Rutherford's model is also known as planetary model. So now we have seen the atom model done by Rutherford. So this is the atomic model, the basic atomic model which we are using now also. Okay, so according to Rutherford's model, the atom consists of a very small massive part. The whole of the positive charge is concentrated in that massive small part, and that part is known as nucleus. And the electrons are revolving around the nucleus in some specific orbits. And the force of attraction between the positively charged nucleus and the electron is the Coulomb's attractive force. So this is the first model which is given a satisfactory explanation of the experiments on atomic structure. But this also has got some disadvantages or some drawbacks. The main drawbacks of Rutherford's model is it could not explain the stability of the atom, and also it couldn't explain the discrete wavelengths produced in spectrum. So I think all of you have understood this Rutherford's model, and in another videos you can see what is the Bohr's model of atom, which is the new model done by Niels Bohr.